All right, welcome back again for Algebra 2, Target 38. I can use trigonometry to solve right triangles. This is the third and final part of Target 38. Today we're going to look at finding missing angles. So basically the idea here is if I have two sides, or three sides of a right triangle, and again, if you have two, you have three because you can always find the third side using the Pythagorean theorem. But with two sides, I can find the two acute angles. All right, so here I'm looking for this angle right here, theta. I know the hypotenuse. And then the other side is the side that's helping create that angle, so that makes it the adjacent side. All right, now, based on what we know about trig definitions, the two trig ratios that use adjacent and hypotenuse would be the cosine. So we know that the cosine of theta is equal to the adjacent over the hypotenuse. Or we could use secant of theta equals hypotenuse over adjacent. Now, typically we want to use sine, cosine, and tangent for these because it's going to be easier with our calculator. We could use secant, cosecant, or cotangent, but it doesn't really make a whole lot of sense. So let's cross this out. We're going to use cosine. So if we fill in what we know, we have the cosine of theta equal to the adjacent, which is 6, divided by the hypotenuse, which is 11. All right, so what we want to do is we want to get rid of this cosine. Now, we can't divide by cosine. There is no dividing by a trig ratio. But what we can do is we can take the cosine inverse of each side. So if we take the cosine inverse of the cosine, those cancel each other out. And then over here, we'll take the cosine inverse of 6 over 11. Right? So again, these two things cross each other out, and we're left with just theta equals cosine inverse of 6 over 11. So how do we do this cosine inverse? How does that work? Well, it's just a matter of using our calculators. So if we bring up our calculator, notice that the second function of all of these keys, if you have the sign right above it, is sine inverse. Cosine right above it is cosine inverse. Tangent right above it is tangent inverse. So those are inverse functions that we can use to get rid of sine, cosine, or tangent. So in this case, we want the cosine inverse. So again, we want to double check our mode to make sure that we're in degree mode, which I am. And then we're going to type second cosine, which will bring up cosine inverse of 6 over 11. So 6 divided by 11. And make sure you put your parenthesis on there. And we get 56.9442. So this is the degree measure of the angle. All right, so cosine inverse of 611 is 56.94. So we can see our answer up here, letter C, 56.9 degrees. All right, so we use these inverse trig functions to find angle measures. Okay, putting this into play in a problem. Here we've got a monster truck drives off a ramp in order to jump onto a row of cars. The ramp has a height of 8 feet and a horizontal length of 20 feet. What is the angle theta of the ramp? All right, so we are given that the height of the ramp right here is 8 feet. Be a bad color to use. Let's use red. 8 feet for the height, and then the horizontal length is 20 feet. And we want to find this angle over here, theta. All right, so if we look at the sides here, this is the hypotenuse that the monster truck is driving up onto. The other side that helps make the angle is the adjacent, so that's the 20 feet, leaving this as the opposite. All right, so since we know opposite and adjacent, the trig ratio that we're going to use to set this up would be tangent. Because we know that the tangent of theta is equal to the opposite over the adjacent. So put in the numbers we know. So we've got tangent theta equals 8 over 20. So then take the tangent inverse of both sides. So you get theta equals tan inverse of 8 over 20. Which is going to be approximately, we go to our calculators now, do second, let's clear this, second tangent of 8 divided by 20. And we get an angle of about 21.8 degrees. So 21.8, and this again, this is an angle measure, so this is in degrees. A few more examples here. Let's take a look together at number 11. All right, so here I'm looking for this angle. This side is the hypotenuse. Okay, this other side that helps create the angle is the adjacent. So those are the two sides that I'm working with, which means the trig ratio I would use for adjacent and hypotenuse would be cosine. So that's the equation, the definition we're going to use to set this equation up. So cosine of theta will equal 4 over 9. And then to get theta, we just do cosine inverse of 4 over 9. And calculating that, second cosine 4 divided by 9, it's 63.6 degrees. Alright. Okay, why don't you try number 12 now? You can pause the video, give it a whirl. When you're ready, restart. Alright, so here's your angle that you're looking for. This is the hypotenuse. We don't know that. Okay, this other side that helps create the angle is the adjacent side, leaving this as the opposite side. So the two sides we know are opposite adjacent, which means we're going to want to use tangent of theta, which is equal to the opposite over the adjacent. So fill in what we know. Tangent theta equals 10 over 8, and then do tangent inverse of 10 over 8. So calculator, second tangent 10 divided by 8. And we get 51.3 degrees. Okay, one more example. Okay, again, try this one on your own. Pause the video. Okay, so in this problem we're looking at theta there, okay, which makes this we know is the hypotenuse. It's across from the right angle. This other side that helps create my angle is the adjacent side, which leaves this as the opposite. So this time we know the opposite and we know the hypotenuse. So the trig ratio that uses those would be sine. So sine of theta equals opposite over hypotenuse. Again, that's just the definition, right? All we're doing with these is using the definition to set up an equation. So write in what we know. Sine theta equals 5 over 12. Do the sine inverse. And then we calculate that. So second sine 5 divided by 12, and we get 24.6 degrees. All right, so that's it for target 38. So when we want to find an angle, we use inverse trig ratios. But again, set it up using your definition. We always set things up using our definitions based on the side we know and the side that we're looking